Hello friends, let us now start our discussion with structure of atom. Actually, if you see an atom, this atom consists of mainly the empty space, and its mass is mainly concentrated at the central nucleus. Okay, this is actually at the central nucleus. The mass of the atom is concentrated at the central nucleus. This nucleus contains A. It contains some number of, it has nucleons. What are these nucleons? Nucleons are the charged particles which are present in the nucleus, or the particles. They are not charged, they can be neutral charge, they can be positive charge, but these nucleons are the particles or which are present in the nucleus. They include protons and neutrons. Okay, now then surrounding the nucleus we have orbits, and inside the orbit you will see the electrons which are revolving around the nucleus. So this is electrons. So these are electrons which are revolving around the nucleus. Now, some important terminology, if you see, A is called as mass number, that is this mass number is the number of protons plus number of neutrons is called as mass number. Actually, electrons have negligible mass. They have very less mass. So as a result, when we add the protons with the neutrons, the mass that we get is called as mass number. Now, one more important thing is about Z. Okay, what is Z? Z is actually an atomic number. This Z is an atomic number, and this Z also represents the number of protons which are present. It represents number of protons. Z is an atomic number. It also represents the number of protons which are present. So, then how do you calculate the neutrons? So, as we have already said, mass number is equal to protons plus neutrons. So, neutrons is equal to mass number A minus protons. Protons is nothing but atomic number which is Z. So A minus Z will give the number of neutrons. Okay, next. Next, what is a nuclide? Nuclide. Nuclide is actually a species of nucleus. It is a species of nucleus, and this nuclide consists of two numbers. Nuclide consists of two numbers, that is Z and A. Z is atomic number, A is atomic mass. Then now if you see, fine. Now if you see some fundamental particles which are present and their relative charges we will see. Okay, in the fundamental particles and their relative masses, first we have nucleons. Nucleons, as we have already said, they are the particles which are present in the nucleus, which include neutrons and protons. Okay, if we see relative mass, we generally look at relative mass. The relative mass of neutrons is 1 and protons is also 1. And if you see the relative charge, obviously neutron has no charge, 0, whereas proton has +1 charge. And if you see the symbol of neutron is N and proton is P. Similarly, if you see extranuclear, that is outside the nucleus, we have an electron. Outside the nucleus, we have an electron. And in the electron, if you see the relative mass of electron, it is very, very less, that is 0.00054. That is very less when compared to either proton or neutron. Then if you see the relative charge, the charge of electron is obviously -1. Then if you see the symbol of electron is E minus or beta minus. Okay, next. If you see other particles, in the other particles we have number 1 positron. The relative mass of positron is 0.000, 3 zeros and 5 fours. Relative charge is +1 and the symbol is electron E plus and beta plus. Similarly, we also have alpha particle. In the alpha particle, the relative mass is 4 and relative charge is +2 and the symbol is alpha. Okay, so this is about the fundamental particles. Now, if you write representation of a element, so if you see an element, if you see carbon 12 6, if I write it as carbon 12 6, then it refers to as 12 is equal to atomic number and 6 is atomic mass. Sorry, 12 is equal to mass number or atomic mass and 6 is equal to atomic number. And this can sometimes be called as C12. On the other hand, there can be C14 and 6. This means atomic number here is 14. Atomic mass. Atomic mass is 14. Atomic number is 6. Then the number of neutrons is equal to atomic number minus Z. That means 8 neutrons. So, if you see here, normally, here the neutrons are equal to 6. So this is stable because there are 6 neutrons and 6 protons. But here in C14-6, neutrons are more than protons. So because neutrons are more than protons, this is unstable and this is radioactive. Okay, so this, because of its radioactivity, it is called as radionuclide. Okay, because of its radioactivity, it is called as radionuclide. Right. Now, if you see, there is a nucleus. Surrounding the nucleus, we have orbits. Like the sun has nucleus and planets has different orbits. We have different shells. So this is actually the nucleus. Surrounded by, we have shells like K, L, M and so on. From center to outwards, we have K, L, M, N and so on shells. And then in the K shell contains 2 electrons, L shell contains 8 electrons, K shell will contain 2. So if you take this picture, here there is KLM shell. If there is 1 electron, so the outermost shell, in each atom we have the outermost shell, or which is also called as valence shell. And this outermost or valence shell, this is the shell which is very important. Why? Because it is concerned with chemical property of the element or thermal property, or it is concerned with optical, and it is concerned with electrical properties of elements. So this outermost shell is the one which is concerned with chemical, thermal, optical and electrical properties of the element. Okay, now this is about the outermost shell, right? Outermost shell is about chemical, thermal, electrical and optical properties. What about the X-rays? Are these outer shell? Is X-rays concerned with outermost shell? The answer here is no. The X-rays is not concerned with outermost shell. Actually, X-rays The properties of X-rays and their interaction with materials is mainly important for those of inner shells. Okay, X-rays are mainly concerned. Obviously, the properties of X-rays is concerned with sorry concerned with orbiting electrons. But where are these orbiting electrons? These are mainly in the innermost shells. Mainly the electrons in the innermost shell, they are important for X-rays. That is, these electrons which are in the innermost shell. These are the electrons which are important to determine the properties of X-rays. Okay. Next. Next, in the radioactivity, we have one more important thing about alpha part. We have three types of particles in the radioactivity: alpha particles, beta particles, and gamma rays. So these gamma is a rays, whereas alpha particles are helium atoms. These are actually protons. Okay. Then we have beta particles are nothing but electrons, whereas gamma are the rays. Next. In the valency shell or the last shell, this is the outermost shell or valency shell. This valency shell will never have electrons more than 8. There will be less than or equal to 8 electrons only. It will not have the electrons. The valency shell has more than or less, they will not have more than 8 electrons. Okay. Then if you see the normal metal things like any types of metals like sodium will have one electron, sodium, potassium, all these can have one electron. Magnesium will have two electrons, or aluminium will have three electrons. So metals generally have 1, 2, 3 valence electrons. Okay. Now, when the metal loses its valence electrons, these metals can lose their valence electrons, then they become ionic. Like, for example, sodium can lose this one electron and it forms Na plus. Magnesium loses the two electrons and it forms magnesium Mg plus 2. Similarly, aluminium loses three electrons and it forms Al plus 3. So, as a result, these are good conductors of heat and electricity. So, because of this valency or the property of loss of their electrons, they are good conductors of heat and electricity, which is very important to know. So, now, one more important thing is about the silver bromide. If you see an example, just we will see an example. Silver bromide, AgBr, it is actually an ionic crystal. Why? Because it contains equal number of positive silver ions, that is Ag plus is equal to Br minus. The number of positive silver ions is equal to the number of negative bromide ions. Here silver lost an electron and it becomes Ag plus, whereas bromide has gained an electron and it becomes Br minus. So the number of charges, or there are equal number of positive and negative charges in this AgBr. Okay, here these Ag and Br, this is held by a type of attractive force which is called as electrostatic attraction. Okay, so these both are held by electrostatic attraction, and this electrostatic attraction is seen in most of the three-dimensional lattices. In most of the three-dimensional lattices, you will see this type of crystalline structure is seen. If you see other examples of this crystals. So these crystals are, we have AgBr, okay, then we have sodium iodide or cesium iodide, okay. So these sodium iodide and cesium iodide are used in imaging equipment, okay, because of their equal number of positive and negative charges, and their things we are using this sodium iodide and cesium iodide in imaging equipment, okay. Next important thing is about the binding energy. Okay, what is this binding energy? So this binding energy is an atom. If you see any atom, it is described as ionized. When do you say that it is ionized? Either it should lose an electron or it should gain an electron. Okay, then it is said to be an ionized. So for example, if the if an atom A has lost an electron, then it becomes, electron is lost and it becomes A plus. It becomes a positive charge. Okay, this electron which is lost is negative charge. Okay, so these both positive and negative charges together, we call it as ion pair. And now this atom is said to be ionized. An atom is said to be an ionized when it removes an electron and it becomes positive charge, electron is a negative charge. So both these will form an ionic pair together. Now, we have, if you see, I'm saying the electron is lost. But if you see this picture, okay, this is the nucleus bounded by electrons. Now the question is it easy to lose an electron? Is it so easy to lose an electron always? Is there no relationship or attraction or any force between nucleus and electron? That is one thing, right? See, this electron is moving around the nucleus by a force. Okay, it is balanced in its position by centripetal and centrifugal forces, definitely. And similarly, there is an ionic attraction because this is negative charge. This is positive charge because of the protons which are present in nucleus. So definitely there is an electronic attraction between this positive charge and the negative charge. But it is not falling, but this electron is not falling inside the nucleus because of its opposite force, which is counteracting this pull, electrostatic pull. So, if you have to remove an electron from its orbit, we need an higher energy. Then, one important thing is here binding energy. What is this binding energy? Binding energy is the energy needed to completely remove the electron from its orbit. Energy needed to remove an electron. That is called as binding energy from orbit. Now, if you see the binding energy, this binding energy, what does this depend on? This binding energy mainly depends on the shell of the electron. Which shell is it in? How? See, if you see here in the nucleus, we have some orbits which are nearer to the nucleus. Similarly, we have some orbits which are away from the nucleus. K is nearer to the nucleus, so obviously it has more force of attraction from the nucleus when compared to L and M. So the binding energy or energy required for the removal of electron is more in K shell than L shell than M shell. It is quite simple because K shell is nearer to the nucleus, so obviously it needs more energy to counteract the attractive force which is present between the nucleus and the K shell. Similarly, if the nucleus has to be removed from M shell, it requires far less force than that of K shell because this M shell electron is farther away from nucleus. So the force that with which the attractive force between this M shell electron and nucleus is less. So as a result, it can be easily removed from its orbit. Okay, this is one thing depending on shell. Then this M shell electron. Okay, this binding energy, number one, it depends on shell. Number two, it also depends on uh, atomic number. Okay, it also depends on atomic number also. That means element. That means binding energy is, so if you see, the binding energy is directly proportional to atomic number. That means as the atomic number increases, the binding energy increases. So that means if you see, sodium binding energy is less than potassium, or if you see, you can say magnesium less than aluminium, because atomic number of sodium is 11, magnesium is 12, and aluminium is 13. So binding energy of sodium is less than that of magnesium, is less than that of aluminium. Okay, now this is one thing. Now, excitation of electron. Okay, an electron, if you see, now in this, if an electron is first, if an atom is excited, if an atom is excited, that means an electron can be moved from one shell to another. That means if this is an electron, this electron can move from this shell to other shell. So then we say that the atom is excited. Okay. For this, we need some expenditure of energy. Energy is used for this process. Okay. First, it will move from one shell to another shell. Okay. Then we say that electron is excited. Next. So now, if you see, just this is just for an example. Now if you see this electron which is here, it went to here now. Okay. So, okay, now this is not there. Now the energy, this electron will come back to its original position. This electron which is here, okay, it should come back to its original position. While it is coming back, while it fall back to its original position, then it releases some packets of radiation, which is called as quantum aspects of electromagnetic radiation. So when electron falls back, then some energy is emitted. Some energy is emitted as photon of light. As photon of light. Either this light can be visible light or it can be an ultraviolet light. Okay, so this is one of the type of electromagnetic radiation. So these are important points about the atom. Thank you.